Hello, my name is Rob Reynolds. Welcome to Calculus Section 5.4, and today we're going to be learning some techniques about even and odd integrations that will help you quickly solve some integrations, some difficult integrations that will make it a little bit easier, and we're also going to be talking about the mean value theorem and the average value theorem. So I think you'll like this lesson. Not too bad. First of all, we need to talk about even and odd functions again. A function is an even function if every time you replace x with negative x, you get the exact same function back. So the most common even function that you know of is this y equals x squared. So again, if you replace x with a negative x, you get the exact same y value. So there's your first look at an even function, which I suppose you've seen before in your Algebra 2 days. Then your odd function, probably the most common odd function, is the y equals x squared. Look what happens if you replace every x with negative x. That's what you do to determine if it's even or odd. If you get the same function, which you did over here, then it's even. If you get the opposite, which you do over here, do you see how this is the opposite of y? If you get the opposite, then it's an odd function, and it has symmetry about the origin. So you can kind of remember the 3-0 rules, opposite, odd, and origin. So that's your even and your odd function. Well, the neat thing about it is an odd function has area of 0, because you would have positive area and you'd have negative area, and that would just cancel out if it's odd. And if it's an even function, then you, instead of integrating from like -3 to 3, you could just integrate from 0 to 3 and then double it because you have symmetry. So that's why they're saying 2 times from 0. So if they ask you to use symmetry, you must use symmetry. Now I know you could still integrate this the old way and then evaluate it from -2 to 2 and do the fundamental theorem of calculus, f of 2 minus f of -2, and still get the right answer. But as you've learned, this course is not about the answer, it's about your method of madness, and you need to show me that you can do this through symmetry, which means, well, let's determine if this is an even or odd function. Well, actually, the integral of a minus b is really the integral of a minus the integral of b, so I see that you have an even function here. The integral of this, that is even. So I think we'll just go from 0 to 2 and then double it. But this next guy, if I pop out the 3 by using the constant rule, is an odd function. And I think that's just going to go to 0. So this would be -3 times 0 because I'm going from -2 to 2. But this is an odd function. So that's why this whole thing goes to 0, which helps me a lot. I don't have to integrate that at all. The only thing I have to integrate is this over here. So integration means take the 4 and increase it to a 5, divide by the 5, end up with 2/5. All of this has gone to a 0, so all I have to do is evaluate that between 0 and 2, because I've already doubled it with this 2 here, that's this 2 here. And then you would show me the f of b minus f of a, but, well, I would have 2/5 times 2 to the 5th minus 0, and then the final answer is 64/5. So again, lots of ways you can get the correct answer, but it's showing me that you can use symmetry to do this. So cosine functions could be even, could be odd, depends on the interval that you're going to choose. So we need to remember what the cosine function looks like. But this is from 0 to 2 pi, and they're saying, oh, only look at it between -pi/2 and pi/2. Where the heck is pi/2? Right there, pi/2. So maybe it's just right in here. So now you can see that's an even function because that area is the same as that area. So I'm going to double it. 2 times 0 to pi/2 would give me the same area as just the whole integration between -pi/2 and pi/2. And then this guy, well, again, you might want to look at the function. It could be even, could be odd, depending on the interval. So there's your sine function, but if I drag that over here, this is negative, this is positive, this is your -pi/2, this is your positive pi/2, and I think that's just going to go to 0. So 4 times 0, and that's just -0. Don't have to worry about that again. So the integral of cosine is sine, and then evaluate that here. You need to know a little unit circle. I like to pull this out and just evaluate your f of b minus f of a. So it's that constant rule. I'll just pull out the 2 and just do the sine of pi over 2 is 1, and the sine of 0 is 0, and the final answer is 2. So that's using even and odd functions. Again, you could go through this whole thing. I'll count the answer wrong if you don't use symmetry. I'm not really interested in that method. And then there's part B. So halfway through, we're done with even and odd functions. Now, I told you at the beginning of the video that we'd also talk about the average value function and then the mean value, and it means pretty much the same thing. If you take a test and 1, 2, 3, 4, 5 tests, you add them up and divide by 5, that's how you find the average. So that distance between 0 tests and 5 tests is your interval. So when you're finding the average value, you're really taking 1/5 of all of the sums of your test scores. So this is kind of like your 1/5, and this part is the sum, if you remember from 5.1 Riemann sums, of all the areas, those infinitely many rectangles that you throw underneath the curve. So there's the formula for average value function, and here's how it works. Finding the average value is denoted as f bar, just like x bar, if you took statistics, means the average or the mean. You add them all up and divide by however many n's you have. So the average f is 1 over b minus a, and then integral from a to b. So fairly simple. We just have to figure out what this interval is. Well, they gave it to me. There's your a term, there's your b term. So 1 over 5 minus 0, and then integrate this whole function, 60x cubed minus blah, 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 blah. So all you're going to do is integrate this thing and then evaluate it from 0 to 5. So we'll integrate this thing 64, so I'll reduce that in just a moment, minus 650x cubed. All I'm doing is increasing that to a 3 and then dividing by it. Plus 1200 divided by 2x squared. Do you see what I'm doing? If not, shoot me some email. And then evaluate that from 0 to 5. Well, if I throw in a 0, it's gone. If I throw in a 5, and then 5 for every x, and then take 1/5 of it, you'll get around 3,958 and 1/3. So number crunching, I'll leave that up for you to check out. But there's a good representation of the average value. So there's the function, and then there's the average elevation of this function. It's varying different heights along the way, but its average is around 3,000. That's the average value function. The mean value theorem says there's some point at where there's an average. So you're finding the x value. And that's the only difference between the mean value theorem and the average value theorem. The mean just says there's some x value. Sorry about that. So look, the formulas are the same. The formulas are the same. But the mean value theorem is finding some point. And so the mean, there is some point, some x and y value, where here was just, some y value is the average. But up here, you're saying, okay, at that x value, it hits the y value average. So let me show you what I mean. Average value. So for average value, we do the 1 over b minus a, and then integrate the function. So 1 over, it looks like I'm going between 1 and 0, and integrate between 0 and 1 again of that 2x, 1 minus x. Well, I'll probably multiply them together, 2x minus 2x squared, and then integrate that between 0 and 1. Of course, this is just a 1 hanging out there. So x squared minus 2/3 x cubed between 0 and 1 gives me a 1/3. So what does that 1/3 say? That 1/3 is the average value. And you may think we're done, but it says find the points on the interval at which it equals the average. So you want that 1/3 to equal, that is the, or you want that to equal the function. Find out where that 1/3 is, f of x. So we're kind of moving from the average value, which says, okay, there's the average, which was 1/3, but now it's saying kind of, it doesn't ask for the mean value, but kind of indirectly it does. It's saying find that point, some point C, so that it creates the average. So all you do is you set that average value equal to the function itself, 2x 1 minus x. So 1/3 is equal to the 2x minus 2x squared. Oh, I'll probably set that equal to 0 minus 2x minus 1/3 equals 0. Probably multiply through by 3, try to factor it, or just use my calculator. Guess left, guess right, guess on, and go for some decimal answers. You could always use the quadratic formula as well. But again, they use the quadratic. Isn't that nice to find exact answers? Good. I hope that's a skill that you have. So again, more using symmetry, I would double this and go between 0 and pi over 4 because that's an even function. And then if you graph this, you'll find out every time you replace x with negative x, so f of x gets replaced with f of negative x, and it's the opposite, which is what's going to happen here because this goes to negative x over, and this would be the same. So see how that would just go negative. So this is an opposite, so I know this answer is going to be 0 because this is an odd function, and I just saved myself tons of time. Now remember, that only happens when you go from -10 to 10. If you were to do this from -5 to 10, then of course that doesn't give you the same amount of area on the left side that it does on the right side. So you have to make sure that the area above is equal to the area below. And then back to this problem over here, you can finish this one up by saying 2 sine x from 0 to pi over 4. And I hope you know unit circle. The sine of pi over 4 is the square root of 2 over 2, which is just the square root of 2. So know your unit circle. So average value function says, again, we're going to, can I jump to, I just did, I'm wondering if I should do 24, but for sake of time, maybe I should jump to 26. I see that I have a doubling, I better do them both. Okay, so for 24, I'm going to do 1 over b minus a and then integrate the function. So 1 over, let's see, pi over 4 minus the negative pi over 4 is negative 2, 4, pi over 2, which reduces to, or instead of dividing by a fraction, I get 2 over pi. I think I did that right. And then I'm going to integrate from negative pi. I wonder, negative pi over 4 to pi over 4. I think, is this an even or an odd function? I should probably, does it say use symmetry? Well, I could probably use symmetry. I'm not going to. I could probably go from 0 to pi over 4 and confuse you some more, but let's just not use symmetry on this. It doesn't say to use symmetry, so I guess I don't have to. But the question becomes, how do I integrate this double angle? And so you could do a quick let u be 2x, then du would be that 2. And then so you have to remember to end up with an extra 2 here when you integrate 2 dx, which really means that du divided by 2 is gets replaced with my dx. So really a 1/2 pops out. And when you multiply by that 1/2, which is that du, that part of that du, you can see that kind of cancels, leaving me with just 1 over pi. So I'm still integrating cosine, and that's a u now. So this new problem was the integral of cosine of u du, and that du was that was 1/2 du, but I popped out the 1/2 here. There's the du. And the integral of cosine, of course, is sine u, but u is 2x, and then I would evaluate that from negative pi over 4 to pi over 4. Then do the fundamental theorem of calculus and keep the 1 over pi times 1 minus a negative 1 when I evaluate, and end up with 2 over pi. Well, probably a good thing I worked out that one. How about number 26? This is the one I really wanted to look at. 1 over b minus a. Well, that's just the ln of 2 minus 0. And then integrate e to the 2x dx. Well, the integral of e to the 2x, again, I could do a little let u statement. Let u equal 2x, then du is that 2 dx again. And once again, I get 1/2. That needs to pop out. 1/2 du is my dx, so pop out a 1. So I already have a 1 over ln of 2, and I pop out the 1/2, creating a 2 down there. And then the integral of e to the u is just e to the u, but u is that 2x. And then go between 0 and the ln of 2. So I don't think I can do anything with this guy, so I'm going to leave him. 1 over 2 ln 2, and then that's just the constant that pops out, but it's e to the 2 ln 2 minus e to the 0, because 2 times 0 is just 0. So this is actually, if I dump this up, e to the ln of 2 squared, which you know is e to the ln of 4, which you may just know as 4. So if this is a 4, this is a 1, and 4 minus 1 is 3, and then that goes in the numerator. So I think my final answer is 3 over this guy, 2 ln 2. Let's see if the author got the same thing. Oh, well, then they went to a decimal form, but at least they got the same answer. So this one says find the points. So we're going to just find the mean and then set it equal to the function. So again, 1 over b minus a, then the integral of 8 minus 2x dx is 1/4 8x minus x squared between 0 and 4, which turns out to be 4. So I don't know, do you want to see a little bit more? I did a little bit in my head here. So 1/4, and then throw in a 4 here, minus 16. That's the 4 minus, and then it's, I don't know, 0 minus 0 if you want to see it all. So this is 1/4 of 16, 32 minus 16 is 16, and then again, that's 4. But the important thing is you're not done, because it says find the points. So all you have to do is set that average 4 equal to 8 minus 2x, and give me the x value. So negative 4 equals negative 2x, excuse me, and x is 2. And if it says find the point, you probably want to go evaluate the function at 2, because that would be your x and your y value. So just go back into the function and plug in a 2 right here. So 8 minus the 4 gives you a 4. So the point would be 2 comma 4. I hope you found this video helpful. There's some more practice with this e to the x. I think you'll be okay. If not, check out Blackboard, because all the worked out solutions are on Blackboard. And it's right here. The worked out solutions right here too. That was a good problem. So make sure you do number 36. And there's a story problem for you to look at as well. So 47 is worked out again online as well. Good luck.